Hello, in this lecture we will find the value of x using two different methods. In the drawing we have the right triangle ABC. We know that angle BAC equals to angle BAD equals to alpha, angle DAE equals to alpha, angle EAC also equals to alpha. And we also know that BD equals to 3 units, DE equals to 4 units, and we want to find out the value of EC that is equals to x. So I will present to you the angle bisector theorem. Actually, in triangle ABC, AD is angle bisector. AD is angle bisector because it bisects angle BAC to two equal parts. If this angle is theta, then this angle will be also equals to theta. Okay? So angle bisector AD bisects angle BAC, or divides angle BAC to two equal parts, theta and theta. And according to angle bisector theorem, an angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angle legs. So according to angle bisector theorem, I will read the angle bisector theorem again. An angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angle legs. Okay, so the angle bisector AD eats side BC of triangle ABC, and it divides side BC of triangle ABC into a ratio that equals to BD over DC. And that ratio equals to the ratio between the angle legs. The legs of angle BAC are AB and AC, and the ratio between the legs is AB over AC. AB over AC. So the ratio that angle bisector AD divides side BC of triangle ABC is BD over DC, and that ratio equals to the ratio between the angle legs, that is to say, it equals to AB over AC. Again, the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is to say, AB over AC. Okay, so that is the angle bisector theorem, and we will focus on the right triangle, triangle ABE, on the right triangle, triangle ABE. Actually, AD is angle bisector in the right triangle ABE. AD is angle bisector. Again, in the right triangle, triangle ABE, AD is angle bisector. So why AD is angle bisector in the right triangle, triangle ABE? Because of the fact that angle bisector AD divides angle BAE to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle, triangle ABE. And according to angle bisector theorem, the angle bisector AD divides side BE in a ratio of BD over DE. Okay? Again, the ratio that angle bisector AD in triangle ABE divides side BE is BD over DE. And that ratio, according to angle bisector theorem, that ratio equals to the ratio between the angle legs. And the legs of angle BAE of this angle are AB and AE. And the ratio between those two legs is AB over AE. Okay, it equals to AB over AE. Okay, so the ratio that angle bisector AD divides side BE is BD over DE, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs is AB over AE. So those two ratios are equal to each other. Okay, and what is the value of BD? BD equals to 3 units according to what is given us in the question. And DE equals to 4 units according to what is given us in the question. So In total, we got that AB over AE equals to 3 over 4. AB over AE equals to 3 over 4. And we will define AB as 3K, that is to say AB equals to 3K, and we will find out what is the value of AE. So first of all, we will place the 3K inside this equality, and we will get that 3K over AE equals to 3 over 4. So we substituted the value of AB by 3K because AB equals to 3K, and we will find out what is the value of AE. Okay? So we will multiply this equality by AE, and we will get that 3 over 4 times AE equals to 3K. Okay, got that 3 over 4 times AE equals to 3K. Here we will multiply this equality by 4, and we will get that 3 times AE equals to 12K. Here we will divide this equality by 3, and we will get that AE equals to 12 over 3 is 4, so AE equals to 4K. So we actually found out that if AB equals to 3K, then AE must be equal to 4K. Okay? So we will continue to focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus DE square equals to AE square. AB square plus PE square equals to AE square. Okay, according to the Pythagoras theorem, in the right triangle, triangle ABE, AB square plus BE square equals to AE square. We know that AB equals to 3K according to our definition, so AB square will be equal to 3K square plus BE square. What is the value of BE? BE equals to 3 plus 4, that is to say to 7. BE equals to 7, so it is 7 square. It equals to AE square. We have already found out that AE equals to 4K, so AE square will be equal to 4K square. Okay, so we got this equality. We know that 3k squared is actually equals to 9k squared plus 7 squared is 49. It equals to 4k squared. 4k squared is 16k squared. So here we will subtract 9k squared from this equality and we will get that 49 equals to 16 minus 9 is 7, so in total we will get that is 7k squared. Here we will divide this equality by 7 and we will get that k squared equals to 7. Here we will take a root out of this equality and we will get that k equals to the positive root of 7. K equals to the positive root of 7. And after we found the value of k, we know that AB equals to 3k. So we can place the value of k inside this equality and we will get that AB equals to 3 times root 7 and AE equals to 4k, and we know that k equals to root 7, so we will place the value of k inside this equality and we will get that AE equals to 4 times root 7. So we found out the values of AE and AB. Okay. In the next step we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC. We know that tangent 3 alpha equals to BC over AB. So in the right triangle, triangle ABC, we know that tangent 3 alpha equals to BC over AB. But what is the value of BC? BC equals to 3 plus 4 is 7 plus x. So BC equals to 7 plus x. BC equals to 7 plus x, and we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangent 3 alpha is actually 7 plus x over 3 times root 7. Okay, we found out that the value of tangent 3 alpha equals to 7 plus x over 3 times root 7. In the next step we will focus on the right triangle, triangle ABE. In the right triangle, triangle ABE, we know that tangent 2 alpha equals to BE over AB. Okay, tangent 2 alpha equals to BE over AB. Okay, but what is the value of BE? BE equals to 3 plus 4. That is to say, BE equals to 7 units, and AB equals to 3 times root 7. So in total we got that tangents 2 alpha equals to 7 over 3 times root 7. Okay. In the next step we will focus on the right triangle, triangle ABD. So in the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. On the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. What is the value of BD? BD equals to 3 units. And we have already found out that AB equals to 3 times root 7. So in total, we got that the value of tangents alpha is actually equal to 3 over 3 times root 7. So we actually found out the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha. Okay? But we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha. And in order to find out the value of tangents 2 alpha plus alpha, I will present to you a new trigonometric identity. The new trigonometric identity is tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. Okay, so we will use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. So we get that tangents 3 alpha that equals to tangents 2 alpha plus alpha, it actually equals to, according to this trigonometric identity, tangents 2 alpha plus alpha will be equal to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. Okay, so actually that is the value of tangents 2 alpha plus alpha according to this trigonometric identity. Okay, but we have already found out the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha. So we will place the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha inside this equality, and we will get that tangents 3 alpha is actually 7 plus x over 3 times root 7 equals to tangents to alpha is 7 over 3 times root 7 plus tangents alpha is 3 over 3 times root 7 over all divided by 1 minus tangents alpha times tangents tangents to alpha times tangents alpha, that is 3 over 3 times root 7 times 3 over 3 times root 7. Okay, so we got this equality. Here we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7 in order to have a common factor with this expression. So we will get that 7 plus x over 3 times root 7 equals to, here 7 plus 3 is 10, is 10 over 3 times root 7 over, so we will substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. So we actually substituted 1 by this expression equals to 1. So here we have also minus 3, 7 times 3 is 21. So in total we got this equality. Here we will move this expression to the numerator and this expression to the denominator, and we will get that seven plus x over 3 times root 7 equals to 10 3 times root 7 times 3 times root 7 over 3 times root 7 3 times root 7 times 3 times root 7 minus 21. So here we have 3 times root 7 in the numerator and we have 3 times root 7 in the denominator, so 3 times root 7 will get cancelled. So what is left after we cancel 3 times root 7? Is 7 plus x over 3 times root 7 equals to 10 times 3 is 30, So in the numerator we will have 30 times root 7, and in the denominator we have 3 times 3 is 9, and root 7 times root 7 is 7, and 9 times 7 is 63, minus 21. So here 63 minus 21 is 42, so I write it down. Here we will multiply this equality by 3 times root 7, and we will get that 7 plus x equals to 3 times root 7 times 30 times root 7 over 42. So here 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630. So we got that 7 plus x equals to 630 over 42. So here 630 over 42 is 15, so I write it down. Seven plus x equals to 15. Here we will subtract 7 from this equality, and we will get that x equals to 15 minus 7 is 8. So we found out that x equals to 8 units. That is to say, EC that equals to x equals to 8 units. So we finished with the first method. So in the next step we will find out the value of x according to the second method. We will extend side BD by 3 units. Then we will define this point as point M. So we extended BD by 3 units, therefore MB will be equal to 3 units. Actually, MB will be equal to BD, that equals to 3 units, because we extended BD by 3 units. Then we will join points A and M by a straight line. So what is the size of this angle? We know that MD is a straight line because BD is the side of the right triangle ABD. We extended BD, so BM will remain a straight line. So MD is a straight line. Line segment MD is a straight line. And we have a rule that states that the rule states that the sum of the angles on a straight line is equal to 180 degrees. We'll read again the rule. The rule states that the sum of the angles on a straight line is equal to 180 degrees. And we know that MD is a straight line, therefore along AD we know that the sum of the angles along MD, the sum of the angles is equal to 180 degrees because MD is a straight line, and especially at point B of the straight line MD, the sum of the angles is equal to 180 degrees. Okay, so which angles we have at point B on the straight line MD? We have here ABD is the right angle, so it equals to 90 degrees, plus the size of angle ABM must be equal to 180 degrees. Okay, 90 degrees plus the size of angle ABM must be equal to 180 degrees according to this rule that states that the sum of the angles in a straight line equals to 180 degrees, and MD is a straight line, therefore the sum of the angles on the straight line at point B must be equal to 180 degrees, that is to say 90 degrees, plus the size of angle ABM must be equal to 180 degrees. Here we will subtract 90 degrees from this equality and we will get that angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So angle ABM is a right angle. It equals to 90 degrees. So in the next step we will focus on the right triangles, triangle ABM and triangle ABD. We actually prove that those two triangles can go into each other. So we know that MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. MB equals to BD equals to 3 units. MB equals to 3 units. According to our construction, we extended BD by 3 units. Therefore, MB equals to 3 units. And we also know that those two angles are equal to each other. That is to say, angle ABM equals to angle ABD equals to 90 degrees. Those two angles are right angles, they are equal to each other. And actually AB equals to AB. AB is the common side. It belongs to both triangles. Okay, AB equals to AB. So we actually proved the triangle, the right triangle ABD can go into the right triangle ABM according to side angle side rule. So I'll write it down. The right triangle, triangle ABD, can go into the right triangle, triangle ABM. This is the sign of congruent. So the right triangle ABD can go into the right triangle ABM according to side angle side rule. Okay. So what is side angle side rule? Actually, if you prove the two sides and the angle between them in one triangle are equal to two sides and the angle between them in the other triangle, then you actually proved that the two triangles can go into each other according to side angle side rule. And we actually proved that two sides and the angle between them, those two sides and the angle between them in triangle ABD are equal to two sides and the angle between them in triangle ABM. Therefore, we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, here we know, according to what is given us in the question, that all those angles, it's given us in the question that all those angles are equal to alpha. This is what is given us in the question. And because of the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so I can write down that angle ABD is equal to angle ABM from the fact that the two triangles can go into each other. We can derive that angle ABD equals to angle ABM according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, because of the fact that those two triangles can go into each other, the corresponding angles, those two angles will be also equal to each other. So if we know that angle BAD equals to alpha, angle BAD angle BAD, this angle equals to alpha, and those two angles are equal to each other. Angle BAD equals to alpha. So from this equality we can derive that angle ABM also equals to alpha. So angle MAB, angle MAB, angle MAB So from this equality we can derive that angle MAB also equals to alpha. So we can write here that angle MAB equals to alpha. And we also can derive from the fact that those two triangles can go into each other that AM equals to AD. Again, AM equals to AD. Those two sides are equal to each other according to the rule that corresponding sides and congruent triangles are equal to each other. Okay, so we can write down that AM equals to AD. AM equals to AD. Those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides that are AM and AD will be also equal to each other. And if we define AM as Y, AM equals to Y according to our definition, so from this equality we can derive that AD also will be equal to Y. So if AM equals to Y, then AD will be also equal to Y because AM equals to AD. Okay, so in the next step we will focus on triangle ADC. So on triangle ADC, we know that AE is angle bisector in triangle ADC. AE is angle bisector. Okay, AE is angle bisector in triangle ADC. Why AE is angle bisector in triangle ADC? Because of the fact that AE, angle bisector AE divides angle DAC, this angle, divides this angle to two equal parts, to alpha and alpha. Therefore, AE is the angle bisector in triangle ADC. And according to angle bisector theorem, the angle bisector AE divides DC in a ratio of DE over EC. Again, the angle bisector AE divides DC in a ratio of DE over EC. And that ratio, according to angle bisector theorem, that ratio equals to the ratio between the angle lengths, and the angle lengths are AD and AC, so the ratio between the angle lengths is AD over AC. Again, the ratio that angle bisector AE divides DC is DE over EC, and that ratio equals to the ratio between the angle lengths, and the ratio between the angle lengths is AD over AC, and those two ratios are equal to each other, according to angle bisector theorem. But what is the size of DE? DE equals to 4 units, according to what is given us in the question. And what is the size of EC? EC equals to X. And what is the size of AD? AD equals to Y. So in total we got that 4 over X equals to Y over AC. Here we will multiply equation number 1 by AC, and we will get that four times AC over X equals to Y. So here we will multiply equation number 1 by X, and we will get that 4 times AC equals to Y times X. Four times AC equals to Y times X. Here we will divide equation number 1 by 4 in order to get the value of AC, and we will get that AC equals to Y times X over 4. Okay. According to equation number 1, AC equals to Y times X over 4. So in the next step we will focus on the big triangle, triangle AMC, on the big triangle, triangle AMC. We know that AD is angle bisector in the big triangle, triangle AMC. AD is angle bisector in the big triangle, triangle AMC. So YAD is angle bisector in the big triangle, triangle AMC, because of the fact that it bisects angle AMC. Angle bisector AD bisects angle AMC, this angle. That is to say, angle bisector AD divides angle AMC, this angle, to two equal parts. The first part is alpha plus alpha, that is to say 2 alpha, and the second part is also alpha plus alpha, that is to say 2 alpha. So because of the fact that angle bisector AD divides angle MAC to two equal parts, that is to say to 2 alpha and 2 alpha, angle bisector AD defined as angle bisector because it divides angle MAC to two equal parts, to 2 alpha and 2 alpha. Therefore, according to the angle bisector theorem, the angle bisector AD divides side MC in a ratio of MD over DC. Again, the angle bisector AD divides MC in a ratio of MD over DC. And according to angle bisector theorem, this ratio equals to the ratio between the angle legs, that is to say AM over AC. I repeat again, the ratio that angle bisector AD divides MC is actually the ratio of MD over DC, and that ratio equals to the ratio between the angle legs, that is actually AM over AC. Okay? But what is the value of MD? According to the drawing, the value of MD is 3 plus 3, that is to say 6. The value of MD is 6. And what is the value of DC? DC equals to 4 plus X. What is the value of AM? AM equals to Y according to our definition. So, regard this equation number 2. Here we will multiply equation number 2 by AC, and we will get that 6 times AC over 4 plus X equals to Y. We will multiply equation number 2 by 4 plus X. And we will get that Y times 4 plus X equals to 6 times AC. Here we will divide the equation number 2 by 6 in order to get the value of AC. And we will get that AC equals to Y times 4 plus X over 6. Okay, according to equation number 2, AC equals to Y times 4 plus X over 6, and we have already found out in equation number 1 that AC equals to Y times X over 4. So we have the value of AC in two equations, in equation number 1 and equation number 2. In the next step we will create equation number 3 that states that AC equals to AC equation number 3 states that AC equals to AC, and we will place the value of AC on this side of the equation from equation number 1, and we will place the value of AC in the other side of AC, the other side of the equation from equation number 2, and we will get that AC according to equation number 1 is y times x over 4 equals to AC according to equation number 2 is y times 4 plus x over 6. So here we will divide equation number 3 by y. It is allowable to divide equation number 3 by y because y is the size of side AM of triangle AMD. Therefore, it must be a positive number. It can never be 0. Therefore, it is allowable to divide equation number 3 by y, because y can never be 0. So we divide equation number 3 by y, and we will get that x over 4 equals to x plus 4 over 6. Here we will multiply equation number 3 by 4 and 6, and we will get that 6x equals to 4 times x plus 4. Here we will open the brackets in equation number 3, and we will get that 6x equals to 4x plus 16. So here we will subtract 4x from equation number 3, and we will get that 2x equals to 16. 2x equals to 16. Here we will divide equation number 3 by 2, and we will get that x equals to 16 over 2 is 8 units. So we found out that x equals to 8 units, exactly what we have already found in method 1. So here x equals to 8 units. EC actually that equals to x equals to 8 units. So we finished with method 2. So in the next step I will summarize the lecture. So we actually wanted to find out the value of EC, that is x. We know that ABC is a right triangle, angle ABC equals to 90 degrees. We also know that angle BAD equals to alpha, angle DAC also equals to alpha, and angle EAC equals to alpha. And we also know that BD equals to 3 units, DE equals to 4 units, and we want to find out the value of EC, that is actually x. So in order to find out the value of x, I presented to you the angle bisector theorem. The angle bisector theorem states that an angle bisector in a triangle divides the side that it hits in a ratio that equals to the ratio of the angle legs. So, according to angle bisector theorem, the angle bisector AD, first of all, AD is angle bisector because of the fact that it bisects angle BAC. Angle bisector AD bisects angle BAC. For that reason, it is defined as angle bisector. That is to say, angle bisector AD divides angle BAC to two equal parts, to theta, and therefore AD is defined as angle bisector. So according to angle bisector theorem, the angle bisector AD divides side BC. First of all, angle bisector AD hits side BC, and it divides side BC in a ratio of BD over DC. Again, angle bisector AD divides side BC in a ratio of BD over DC. BD over DC. And that ratio equals to the ratio between the angle legs. And the legs of angle BAC are AB and AC, and the ratio between the angle legs are AB over AC. So the ratio between the angle legs, that is AB over AC, equals to the ratio that angle bisector AD divides BC, that is actually BD over DC. And those two ratios are equal to each other. Again, the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is to say to AB over AC. So those two ratios are equal to each other. So we implemented the angle bisector theorem in our drawing. We focused on the right triangle, triangle ABE. We know that in the right triangle, triangle ABE, AD is angle bisector. Why AD is angle bisector in the right triangle, triangle ABE? Because of the fact that AD bisects angle BAC. It bisects this angle, that is to say, angle bisector AD divides angle BAC to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in the right triangle, triangle BAE. And according to angle bisector theorem, the angle bisector AD divides BE in a ratio of BD over DE. The angle bisector AD divides side BE in a ratio of BE over DE. And that ratio equals to the ratio between the angle legs, that is to say to AB over AE. That ratio equals to AB over AE. The ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is actually AB over AE. So that two ratios are equal to each other. But we know that BD equals to 3 units and DE equals to 4 units. So BD over DE is 3 over 4, so we got this equality that AB over AE equals to 3 over 4. Then we defined AB as 3K, that is to say AB equals to 3K according to our definition. And we place the value of AB, that is 3K, inside this equality. And we got that 3K over AE equals to 3 over 4. So from this equality we found that the value of AE is 4K. So actually, if AB equals to 3K, then AE equals to 4K. Again, if AB equals to 3K, then AE equals to 4K. Then we continue to focus on the right triangle ABE. On the right triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. Again, in the right triangle, triangle ABE, AB squared plus BE squared equals to AE squared according to the Pythagoras theorem. But we have already found out that according to our definition, AB equals to 3K and AE equals to 3 plus 4, that is to say 7, and BE squared is 7 squared, and AE equals to 4K according to what we have already found out. So AE squared is 4K squared. We open the brackets here and we got 3K is 9K squared, 3K squared is 9K squared, 7 squared is 49, and 4K squared is 16K squared. We subtracted 9K squared from this equality and we got that 49 equals to 7K squared. We divided this equality by 7 and we got that K squared equals to 7. We took a root out of this equality and we got that K equals to the positive root of 7. So after we found the value of K, we can place the value of K inside this equality, that AB equals to 3K. So if AB equals to 3K, then and K equals to root 7, so AB will be equal to 3 times root 7, and we place the value of K inside this equality, and we got that AE equals to 4 times root 7. So we have the value of AB and AE. Then we focused on the big right triangle ABC. On the big right triangle ABC, we know that tangent 3 alpha equals to BC over AB. Tangent 3 alpha equals to BC over AB. And what is the value of BC? BC equals to 3 plus 4, that is 7, plus x. So BC equals to 7 plus x. So here BC equals to 7 plus x, and we have already found out that AB equals to 3 times root 7. So in total we got the tangent 3 alpha equals to 7 plus x over 3 times root 7. That is the value of tangent 3 alpha. Then we focused on the right triangle ABE. On the right triangle ABE, we know that tangent 2 alpha equals to BE over AB. Okay, tangent 2 alpha equals to BE over AB. What is the value of BE? BE equals to 3 plus 4, that is to say 7. BE equals to 7, and AB equals to 3 times root 7. So in total we got that tangent 2 alpha equals to 7 over 3 times root 7. Then we focused on the right triangle ABD. On the right triangle ABD, we know that tangent alpha equals to dB over AB. Tangent alpha equals to dB over AB, but we know that dB equals to 3 units. dB equals to 3 units and AB equals to 3 times root 7. So in total we got that tangent alpha equals to 3 over 3 times root 7. So we actually found out the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. And we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, I presented to you a new trigonometric identity that states that tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. And according to this trigonometric identity, the value of tangent 2 alpha plus alpha will be equal to tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha. Then we place the value of tangent 3 alpha from this equality here. We place the value of tangent 2 alpha from this equality here, and we place the value of tangent alpha in this equality from the value of tangent alpha from here, and we got to this equality. Actually here we have only one variable that is missing, that is x. we actually solved this equality, and we found out that the value of x is actually x equals to 8 units. So we found out in both methods that the value of x, that is to say EC that equals to x, equals to 8 units. Okay, so the answer to the question is that the value of x equals to 8 units. That was method 1, and we also found the value of x according to the second method. According to the second method, we actually made here a construction. We extended side BD by 3 units, and we defined this point as point M. We extended BD by 3 units, so MB will be equal to 3 according to our construction. Then we join together points A and M by a straight line, and we actually got this triangle, triangle A and B. What is the size of this angle? Angle ABM. We know that MD is a straight line because of the fact that BD is the side of triangle ABD, and we extended it by 3 units. Therefore, MD stays. It must be a straight line because BD is a straight line. So MD is a straight line, and we have the rule that the sum of the angles on a straight line equals to 180 degrees. So the sum of the angles on the straight line MD at any point must be equal to 180 degrees. And if we focus on point B, the sum of the angles at point B on the straight line MD must be equal to 180 degrees. So which angles we have at point B? At point B we have here 90 degrees, and we have also angle ABM. So 90 degrees plus the size angle of angle ABM must be equal to 180 degrees according to this rule. Okay, 90 degrees plus the size of angle ABM must be equal to 180 degrees. Here we subtracted from this equality 90 degrees, and we got that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So angle ABM is a right angle. It equals to 90 degrees. So then we actually proved that those two triangles can go into each other, because we know that MB equals to BD equals to 3 units according to our construction. So MB equals to BD equals to 3 units. We also know that those two angles are equal to each other. They're both right angles. So angle MBA equals to angle ABD equals to 90 degrees. And also AB equals to AB. AB is the common side, it belongs to both triangles. So AB equals to AB. So therefore we actually proved that triangle ABD can go into triangle ABM according to side angle side rule. Triangle ABD can go into triangle ABM according to side angle side rule. What is side angle side rule? Side angle side rule states that if you have one triangle that two sides and the angle between them are equal to two sides and the angle between them in another triangle, then those two triangles can go into each other according to side angle side rule. And we actually proved that side AB and side DB and the angle between them in triangle ABD are equal to side AB and side MB and the angle between them in triangle ABM. So we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Therefore, those two angles are equal to each other, and if this angle is alpha, this angle must be equal also to alpha. From this equality, if angle BAD equals to alpha, from this equality we can derive that angle MAB will be also equal to alpha. This angle will be also equal to alpha. And from the fact that those two triangles can go into each other, we can derive that side AM equals to side AD. Side AM equals to side AD, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides that are AM and AD will be also equal to each other. That is to say, AM equals to AD. And if we define AM as Y, then AD will be also equal to Y from this equality. So AM equals to Y and AD equals also to Y. Then we focused on triangle ADC. On triangle ADC, we know that AE is angle bisector. In triangle ADC, we know that AE is angle bisector. So why AE is angle bisector in triangle ADC? Because of the fact that AE divides angle DAC to two equal parts, alpha and alpha. Therefore, AE is angle bisector in triangle ADC. And according to angle bisector theorem, the angle bisector AE divides DC in a ratio of DE over EC. The angle bisector AE divides side DC in the ratio of DC over EC. And that ratio equals to the ratio between the angle sides. The angle sides are AD and AC. So the ratio between the angle sides are AD over AC. AD over AC. Again, the ratio that angle bisector AE divides side DC is DE and over EC, and that ratio equals to the ratio between the angle sides, the angle legs, that is actually AD over AC. So those two ratios are equal to each other. What is the value of DE? The value of DE is 4. DE equals to 4. What is the value of EC? EC equals to X. Okay, EC equals to X. What is the value of AD? AD equals to Y. AD equals to Y. AC is AC. So we got this equation number 1. And from equation number 1, we actually multiplied this equality by AC. We got this equality. Then we multiply it by X. We got that 4 times AC equals to Y times X. We divided this equality by 4 and we got that AC equals to Y times X over 4. So we got the equation we got the value of AC from equation number 1. Then we focused on triangle AMC. On the big triangle AMC, we know that AD is angle bisector. Why AD is angle bisector in triangle AMC? Because of the fact that it divides angle MAC to two equal parts, 2 alpha and 2 alpha. Again, angle bisector AD is defined as angle bisector AD because of the fact that it divides angle MAC to two equal parts, 2 alpha and 2 alpha, or in other words, it bisects angle MAC. Therefore, AD is defined as angle bisector in triangle MAC. And according to the rule of angle bisector theorem, the ratio that angle bisector divides MC is MD over DC. Again, the ratio that angle bisector AD divides side MC is MD over DC, and that ratio equals to the ratio between the angle legs. And the ratio between the angle legs is AM over AC, or AM over AC. So the ratio that angle bisector AD divides MC equals to the ratio between the angle legs. Okay? So we know that DC MD equals to 3 plus 3 is 6, and DC is 4 plus 6, and AM is Y. So in total we got in equation number 2 that 6 over 4 plus X equals to Y over AC. We multiply this equality by AC and we got this equality. Then we multiplied equation number 2 by 4 plus X. We got this equation, and then we divided equation number 2 by 6 and we got the value of AC. According to equation number 2 is 4y times 4 plus X over 6. And the value of AC according to equation number 1 is y times X over 4. Okay? So we have the value of AC from equation number 1 and from equation number 2 also. Then we created equation number 3 that states that AC equals to AC. And then we place the value of AC from equation number 1 in this side of the equality, and we replace the value of AC on this side of the equality from equation number 2. Okay, AC, here is the value of AC from equation number 1, and here is the value of AC from equation number 2. We solved this equality. We found out that X equals to 8 units. Okay, so we actually found out that the value of EC that is actually equals to X is equal to 8 units. So we actually found out in 2 methods that the value of X is 8 units. Okay, thank you very much.